the harmonic response of a guitar string. We are having one uniform stainless steel guitar string which is having a length of L, diameter D, which is stretched between the two rigid supports. To have a tensioning effect, we need to apply for the force F1, which is required to tune the string over here. So we need to solve for the harmonic response of this particular string with respect to the harmonic load of F2. So let us solve for this particular numerical in a sequential manner. Let us go for the static analysis, then we will deal with the prestress. So let us go for that one. Set preferences, let us say structural, and just say OK. Once we are setting for the preferences, let us go for the preprocessor. Let us click over here, say element type, say add. Let us say add over here again. Add for the element type of link 1. Let us say 1 and just say OK. So once we are adding for the element type link 1, let us close it. Now we need to go for the real constants in relation with respect to the link 1. So let us go for real constant. Let us say add over here again and just say OK. We are going to add for the real constant set area over here. So area is 50671 e to the power minus 12 and just say OK. Once we are setting our real constant, let us close it. Now we need to go for the material properties. So let us go for material properties. Let us say material models. Let us go for structural. Let us double click on the linear, say elastic, and let us say isotropic. So it is an isotropic property in relation with Young's modulus and density. So let us go for Young's modulus of 190 e to the power 9. So let us enter over here first for the Young's modulus of 190 e to the power 9. Considering our Poisson's ratio value of 0, let us say OK. Now we need to enter for the density value. So density for the given numerical is 7920. So let us go for that one. Let us say 7920 and just say OK. Once we are creating our material properties, so let us come out of that one. Let us say modeling. Let us say create. Now we are going to create for the one-dimensional model starting from the first node to the end of a 31st node. So we are going to create first key points over here. So let us say key points. Let us say in active coordinate system. First key point at a 0, 0 orientation, let us say apply. And next we are going to create at a distance of L, which is specifically given as 710 millimeters. We are having the rest of the units in a meters, so we are going to convert it in the meters. So we are going to use that x distance of 0.71 meters and just say OK. Now we need to create for the lines. So let us say lines. We are needing to create a straight line in between these two and just say OK. Once we are creating our modeling with respect to the geometrical entity, so let us go for finite element modeling. Let us come out of our modeling. Let us say meshing. We need to mesh for this particular model. So let us say mesh 2. According to the given conditions, we can see we are having the specific model which is having a starting number for the node is first and ending over here at the last node of 31st. We are having an F force. Magnitude of F1 is 81 Newton, which is having a roller support at the last node. That means we need to create 31st nodes. So we are going to create with the help of 30 elements. So let us go for size control setting with the help of global number of element divisions 30 and just say OK. Once we are setting our size control global, now we need to say mesh. Let's select that line and just say OK. We can see our model is meshed. We can go for the plot control, numbering. Let us switch on for the node numbers and say OK. We can see we are having the 31 nodes located over here. So once our meshing is over, now we need to come out of our preprocessor as we need to go for the solution option. So let us click on the solution. Let us cross check for our analysis type. So let us click over here for the analysis type. Let us say new analysis. Single click on the new analysis. Please cross check over here for is it on static conditions or not. Let us say OK. Once we are keeping it on static, Next to that one, we need to go for the define loads. Let us say define, let us say apply. For the structural conditions, let us single click on the structural, let us say displacement. We need to apply the displacement on the key points. So let us keep on the key points. According to the given conditions of all degrees of freedom are locked at this particular starting location of the string. So we need to lock for all the two boundary conditions over here. So let us go for that one. Select that proper key point. Just say OK. We are going to lock for all degrees of freedom over here. And just say apply. Next to that one, according to the given, we are having the roller support over here. Roller which is free in x direction and y directional displacement is locked. So let us go for that one. Let us select that particular key point. Just say OK. Let us lock it in a y direction and make other directions free. And just say OK by highlighting on uy. And just say OK. We can see we are creating our displacement locking. Once our displacement locking is over, now we need to go for the external load of force P. So we are again going for force of magnitude F1. Let us go for force and a moment. Let us click on the key point. Now again select that particular key point and just say OK. Now we need to cross check for the dimension is in magnitude is 84 Newton and in the direction of x. So let us go for that one. Force in x direction which is having an 84 Newton as its magnitude. And let us say OK. We can see our force is represented over here. Although we are applying all the entities on the key points, that means we need to apply all the entities on the geometrical entity. So now we need to operate and let us transfer all the external loading and boundary conditions from key point to the nodes. So let us go for transfer to the FE and transfer from key point to nodes. So transfer for all the solid loads whatever we are applying on this particular model, and let us say OK. We are getting our representation back over here for the force and displacement locking with the help of application on the nodes. So let us come out of define load. Let us say solve this particular numerical with the help of current load step. Let us close our status and just say OK. We are going to get a solution within a few seconds. So we are having one node that our solution is done. So let us close it. Now in the next session, how we are going to approach for this particular numerical, we are going to see with the help of pre-stress effect.